Okay, so we're going to begin with the rationale for the outlier formula using the quartiles. Okay, so what you're seeing right now is what a box plot uses, the 5-number summary, the min, that's where your whisker comes from, the first quartile, the median, the third quartile, and the max. I get some questions, well, what happened to the second quartile? The median is the second quartile. Okay, so, all right, this is the big idea right here, is this box, this distance from the first quartile to the third quartile is what we call the middle 50%. Now, it is reasonable for some of the scores, 25% of them, to be to the left of the first quartile. So there's a reasonable amount for this to be left of the first quartile, and of course to be right of the third quartile. We wouldn't want to say that just because it's left of the first quartile, it's an extreme value. Okay, there has to be a minimum that is left of the first quartile. We do have a limit, though. We would consider a value extreme if it's more than 1.5 of this distance from either of the quartiles. So you'll see that here in a minute. So there's our middle 50%. Now I'm going to redraw that middle 50% underneath. Now what I did was, to give you an idea, I somewhat estimated how far these were apart, and then that was about 5. If you count those squares, it's almost just shy of 5. So I multiplied by that 1.5. I went about 7.5 to 8, which would be, 1.5 of this distance to the right. I'm just estimating. Okay, that would be the boundary for outliers. So you could see the max still is within that boundary for the outlier. So it is going to be, every piece of data in this distribution is going to consider fitting the rest of the data. There's no extreme values. Okay, so that's how we would set our boundary right here. 1.5 IQRs above the third quartile. Now we'll do that same thing to the left side. Okay, so I measured approximately the same distance away, 7.5 of those interquartile ranges. I'm sorry, yeah, 7.5. This was 5. I'm sorry, the middle 50% was about 5, so I went 7.5, not 7.5 interquartile ranges, 7.5 squares. So that's 1.5 interquartile ranges to the left of the first quartile. Now, beyond this boundary would be extreme. Okay, but we see the minimum is reasonable compared to the rest of the data. It's not outside of that. Okay, so we'd have no outliers. Okay, so then what's going to happen next is we're going to move to the problems. So I'm just going to let this play pretty quickly. Okay, so the formula, that's basically the formula that I just explained. 1.5 interquartile ranges to the left of the first quartile. And here's just the calculation running through real fast. So for problem number 1, the left boundary is 50.5. As far as outliers go, right boundary 110. I use nice numbers on a number line, and then just estimate from there, just over that. Okay, use nice numbers on your scale, your number line. Don't use decimals or 51 or 53. Use a nice, reasonable number for people to look at. Okay, so then you can go ahead and identify what those exact values are on the boundaries afterwards. 60 is not an outlier, fits the rest of the data. In between the boundaries. 50 is just barely an outlier because it is outside of that. Okay, this is an interesting question. It is likely that they'll ask something like this on the AP. Okay, so if 75, some people do consider 75 a low score in this distribution, only because they don't really get it. 79 is the median. 75 is below the middle. Okay, so if you told somebody, their score was in the 35th percentile, okay, Some people would look at that as a low score. That is not. That's still within the middle 50%. So in this case, we should not consider 75 a low score. It's actually above the first quartile. And that's what I'm going to write next. So it is, I'll erase 79. It's actually 75 that's in question here. It's actually still in the middle 50%. So we do not want to consider that a low score. Under the median, but again, not a low score relative to the rest of the data. Okay, so then we'll let these run. With a 5-number summary, one of the things that I just highlighted, if I give you the 5-number summary, it's assumed that you would know the first number is the min, the second number is the first quartile, then it's the median, third quartile, and max. That's just assumed. They're not going to tell you that. All right, you have to know which of those numbers is the first and third quartile. Now, a mistake students have made in the past that I've seen: do not type these in a list and then expect the first and third quartile to be calculated, because we won't get those numbers. This is the first and third quartile given. All right, so let's go. Let's let the. Oh, I shortened up the formula. Don't shortcut it if that is a question on the AP. Okay, only shortcutted it for the fact that we did it previously. All right, so just let that run. 40's within the range of, in fact, it's actually in the middle 50%. So 60's just outside of our right boundary. So it's an outlier to the right, or an extreme value, extremely high value compared to the rest of the data. All right. The next type is, what if we were not given the quartiles or the 5-number summary? What if we were just given the mean and the standard deviation? Well, now the formula is different. What we would consider without knowing anything else is 2 standard deviations above or below the mean is considered extreme. Okay, that would be, of course, if it's a normally distributed data. Okay, so just a slight difference in formula depending on what they give us. Okay, so that's 2 standard deviations left of the mean, 2 standard deviations right of the mean. So there's how we would set our boundaries in that case. And then we go through and analyze those briefly. This diagram on the number line communicates a lot. So if they say briefly explain, having that number line would communicate quite a bit. Number 4 they tried was a little bit tricky. So instead of giving you the mean and standard deviation, they could ask you, indirectly to calculate that. So if they give you an interval and tell you that those numbers are 1 standard deviation from the mean, you've got to be able to figure out that 100 is the mean. It's exactly in between those, and the standard deviation is 8. So a couple ways to solve that. I showed my work right there. A couple ways to do it. Okay, so now we're calculating the boundaries, 84 to 116. Draw your number line. Make sure that you do demonstrate this. If you give this, you probably don't have to explain much. Okay, it'll take the place of some of your explanation. Of course, give a little bit. Okay, and there's how to do that homework problem.